Here's a classic Calculus 1 example. It says find the value of b that would make f of x continuous everywhere. And f of x is this piecewise function that's comprised of a square root function and a linear function. There's a theorem that says square root functions and linear functions are continuous everywhere on their respective domains. And so the only place that we have to worry about it being continuous at is x equals 4, because that's where our x values are being broken at. And so we're trying to find this b value here, which, because this is a linear function, is related to our y-intercept. So let's take a look at the graph of this piecewise function. Here we have the graph, and we can see that both of these parts are continuous everywhere except at x equals 4. And you'll note that for this linear function, I happen to graph it for a particular value of b. And that value of b is equal to 4, because if I extended this line, you'll see that it touches the y-axis or crosses the y-axis at 0, 4. Another observation you can make is that these two portions of the graph would be continuous if I took my line and I shifted it up 2 units. And so if my b value is currently 4 and I shift it up 2 units, then that would mean my b value would need to be 6. So that's how we can kind of approach this graphically, but let's take a look at the algebraic approach. So we can see here that when we plug in 4 into the square root function, we get an output value of 2, which means that for the linear portion, we need the y value to be 2. So over here on the right, if I plug in 4 into the linear portion and I solve for b, we end up getting that b needs to equal 6.